Yeah, I'm afraid the next 3 talks are all SMB related, so woohoo, go SMB. Yes, then we have AFS after that. So my name's Jeremy Allison. I work in Google's open source programs office. Having said that, no Google lawyers have seen these slides. This is a Samba talk, not a Google talk. So please don't want to hear anyone saying, Google engineer says, because they don't know what I'm saying and they don't really care. So the other thing, this is the same talk I gave in FOSDEM a few weeks ago. And this is so wonderful, I just have to share this. My brother, who still lives in the UK, came over to FOSDEM in Brussels, and he came to my talk, which was nice. You know, he's not technical at all, but he was sat there. And FOSDEM gets rather crowded, so people were pushing up. And a couple of guys sat next to him and were looking at the schedule. And he heard them say, one guy said to his friend, "What's new in Samba? Are those guys still around?" So the question shouldn't be what's new in Samba, the question should be why Samba? So given that, I'm here to answer the question of why Samba, and yes, we're still around. Is there anyone here who doesn't know what Samba is or what it implements? Because if you don't, you're in the wrong talk, go upstairs. Okay, so I'm going to talk about some of the latest things that we're doing, some of the things that we have already done, and some of the things that we plan to take the Samba code. Some of it's a little overview, some of it delves down a little bit deeper. I'm happy to answer any questions that you might have. If you want to ask, just feel free to stand up in the middle of the talk and come to the mics. So, first of all, what does Samba do, and why does it work the way it does? So the piece I work on the most, Samba is a very large and complicated beast. It's a file server, it's a print server, it's an Active Directory server, it's an authentication server, it chops onions, it makes soup, you know. There's a lot of pieces in there. So in the file server, which is the piece I'm going to talk about mostly here, there are essentially 3 layers to it in the internal code. There's an SMB1, 2, and 3 protocol parsing layer. Underneath that, there's actually the really hard part, because parsing the protocol's not that difficult. You can actually download the Microsoft Docs. They document everything these days, which is wonderful. And so people read that and they think, well, how hard can this be? Is this just protocol parsing? We can do that. And then they run into actually making POSIX and Unixes behave like Windows. And that's the thing that is hard. So we have this NTFS, basically a Windows NT file system emulation layer, because the whole thing about SMB is it actually makes, it allows Windows semantics on the wire. And then underneath that, there's the piece that I'm spending most of my time in at the moment, which is the VFS, the virtual file system layer. If anyone's familiar with Ganesha, that's the, I think FSAL is what they call that. In practical, that sounds wonderful, and I'd love to draw you a nice diagram of it, but actually it's much messier than that. The SMB 2 and 3 code is much cleaner. The SMB1 code, a lot of the parsing and the NTFS emulation is kind of commingled in a really ugly way. So one of the things that we're doing as we're moving forward is basically trying to separate that out to the point where we should be able to have a completely separated SMB1 server, which we can then kill. And the rest of it will be a lot cleaner. So working on Samba, anyone remember the Milton Bradley game Mousetrap, or am I just too old? Anyone else play that? Yeah, great. So if you remember trying to put it together, it's kind of like, you know, everyone's working together, pull out cards, you build this thing, this Heath Robinson-like device, and then someone pulls the Mousetrap card and you start the ball rolling or whatever, and at some point it falls off the track always, and there's always something wrong with it. Well, kind of working on Samba and trying to modernize it is a little bit like that. The SMB1 is the Heath Robinson part of it, and that's the bit that is usually causing issues. The SMB2 is much better designed. The SMB1 code, trying to modernize the SMB2 piece and make it clean, elegant, threaded, all the rest of it, while still maintaining SMB1 is what gives us a lot of issues. So what are we going to try and do? So first, die SMB1. Get rid of SMB1. That's a slow and ongoing process. Is there anyone here who still uses SMB1 on their network? Don't be embarrassed. All right, it's just me then. Okay. Why I have the unfortunate, the internet of, well, let's use the polite word, internet of garbage devices that still use SMB1. I still have some of those on my network, and so I still have to run SMB1. But I'm planning to upgrade and get rid of them. The second thing that I'm spending most of my time on is modernizing the VFS, which I'm going to go into a lot more details about. There's also a lot more work to make the middle layer, the NTFS layer, asynchronous with lots of threading under the covers. There's also some performance improvements that I can talk about, clustering improvements, and then there's sort of a grab bag of lots of services, because as I said, Samba is a very huge and complicated beast, and testing improvements, and there's some speculative stuff that right now we're just looking at, but there's no code yet, but I'm going to talk about it anyway. So as I said, SMB1 die. So Microsoft, who are very good friends these days, have a guy called Ned Pyle who's taken it upon himself to make it his sole dedication to destroy SMB1. We removed it. The code is still there. So we got a wonderful announcement saying Samba removed SMB1 basically by changing one line in a default config from yes to no. So right now, out of the box, Samba does not do SMB1 anymore. You have to turn it on, which is very nice. Now, all of the code is still there. It's still polluting the rest of the nice, clean SMB2 code. And you can turn it on as you wish. Eventually, it will go away. So my goal is Samba 5 will have no SMB1 server. It'll be pure, clean, modern file server. And as I say, whenever I finish removing the SMB1 code, that's when I'm going to call it Samba 5. So it's kind of by definition, really. Having that code around, as I said, makes the internal modernization very hard. Everything is path name based in SMB1, and having all this stuff is slowing down the addition of the Unix extensions, which Steve and I are going to be talking about next. So I'm afraid you have me for an hour. So yeah, the SMB1 code is a bit of a boat anchor inside of Samba. The other thing that is causing a problem is a lot of our tests commingle SMB1 and SMB2. So Susie right now is putting in a great deal of engineering time and effort with the help of Cernet, another vendor, to actually modernize our test infrastructure and migrate as many of our tests to SMB2 as we can, leaving a sort of a rump of SMB1 only tests that we will eventually delete. Having said all this, by the way, we're almost certainly never going to throw away the SMB1 client code, because there will always be people out there who have Samba and want to talk to very old legacy devices or old versions of Samba that it'd be interesting. I think in the next talk we should probably ask Steve when the SMB1 client will be code will be removed from the Linux kernel, and my guess is not for a long time. But oh, he wants to delete it now. Okay, fair enough. So the VFS in Samba was originally developed in the 1990s, and it modeled the POSIX API of the time. So it's open, read, write, close, etc. Bunch of other things been added to provide NTFS semantics. Modern Unix, or at least Linux system calls are completely different. We have open@, all of the @ calls. It's now symlink safe if used correctly. Everything takes relative file descriptors. We need to modernize our VFS to match the underlying Linux modern API. So this is currently the large task we're undergoing. The other thing is multi-threaded code. Using credential impersonation, they're not very well served by our current VFS design. So the current VFS design assumes that the credentials will remain the same throughout synchronous calls. As soon as you move to asynchronous or threaded calls, you essentially need to add credentials to a call so that the server can essentially be handling multiple credentials at one go. Linux handles this very well. We already have the capability to attach credentials to our thread pools. FreeBSD, not so much. So unfortunately, the only two Unixes that matter these days are Linux and FreeBSD, really. There are a few legacy ones still around, but they're the only ones that matter. And of the two, right now, only Linux has the per-thread credentials, which make these things quite elegant. So kind of FreeBSD works, but when we do the per-thread cred stuff, it goes synchronous over the covers, so under the covers. So.
Around the fact that glibc is trying hard to
So Christoph asked, how do you get around the fact that glibc hates us and wants us to die and won't let us get at the underlying threads? We make raw system calls. So what are you going to do? glibc simply doesn't expose the interfaces we need. So I wrote my own set res UID with per-thread credentials, and it works. It's tested on 32-bit, 64-bit Linuxes. What are you going to do? Until we get that API, that's what we have to do, and it works. So yes, you do what you have to do to make it work. So what does the new VFS look like? Looks pretty similar to the POSIX calls, except we have a handle, which is the handle for the particular VFS module. Instead of a file descriptor, we have what we call a file struct pointer, which is essentially our internal extra state that we have around file descriptors. And then all the names, again, just like the modern POSIX, modern Linux API, will be relative to the directory file service file system pointer. The other things we're going to do is move the VFS closer to NTFS requirements. So NTFS does some things that are not quite POSIX-y. Our VFS has grown over the years to be more NTFS-like. And this is pretty much driven by Samba using OEMs, who have to do the Windows semantics anyway. So having pluggable VFS modules, rather than using the standard POSIX calls to emulate the NT semantics, which we do in our default VFS, moving those semantics up into the VFS layer to allow the OEMs to plug in their own implementations allows them to get better performance, allows them to get, essentially, to make Samba more useful for what they want to do. So the problem is this modernization is going to take some time, so it's kind of half done for 4.12. I'm hoping the modernization will be completed, at least with all the apt calls finished by 4.13. One of the other changes we're doing, it's not on the slides because I'm still working out the details of that, is essentially drawing the GPL boundary very carefully to say that VFS modules that get loaded into Samba, because Samba is a GPL project, will be under the GPL, but the underlying user-level file systems that those VFS modules call will not necessarily be GPL. We need to sort of clarify things around that. But I've got broad agreement that that's where we want to go. So if you know OEM using Samba, that might be interesting for you. So I don't know whether anyone has seen that picture. It's probably a little too small to see. That was from the Mozilla offices in San Francisco. I love this picture. And that guy's about 6 foot something. And up there it says, you can't read it, but it says, must be this tall to write multi-threaded code. And I still think this is a very valid statement. So a lot of our parsing code is single-threaded. A lot of the mid-level NTFS code is single-threaded. So the way we're doing this is essentially using callbacks. We're moving to asynchronous calls into the VFS. So right now, our main read and write code paths look like pread send, pread receive, prewrite send, prewrite receive, etc. And under the covers, there is a thread pool implementation. Now, has anyone written a thread pool implementation before? Oh, yeah, a few people. Well, and the person whose thread pool implementation we're using right now, it's very hard, as you know. So the goal is for... Oh, yes, as Volker mentions, making something safe across fork, which is what Volker's thread pool actually does. Is very, very difficult to do correctly. Yeah. Not exact, no, but it's very difficult to do correctly. And so the goal is to hide all of that complexity. Volker's been working on that code for 7 years, maybe, or around that time. And we still find the occasional race condition bug in it. This stuff is just insanely hard. So the goal is for us mere mortals to basically use that under the covers by making these asynchronous calls, which underneath will go into thread pools. The next thing is the new impersonation infrastructure, so that the VFS calls will have an impersonation context, which basically passes all of the information they need if they need to attach user credentials to a specific thread, so that any of the file path name operations will be done under that user credential and not as the current credential. Because the problem is, of course, if something goes async, we go back, we pull another request in, that might be coming in under a completely different user context. So we need to make sure that the correct context is used for the path name operations. A lot of performance improvements. We got out of the encryption library business, moving to GNU TLS, sped us up with an encrypted transport by a factor of 3, which was very nice. Volker has been doing a lot of work from Cerner on our internal databases. There are some very pathological use cases that Windows clients do. The classic one is when a boatload of Windows clients come up, they connect to a top-level share, everybody opens their file browser, and every single one of those takes a change notify on the top-level directory of the share. That can end up with a lot of resources on the server, etc. And so there's been a lot of work that's improved our performance done by changing the data modeling there. And in a quick advert, the talk after the next one, Volker's talk is going to be telling you all about the things that he's done there to make clustering and our share mode database more efficient. Lots and lots of small scalability stuff, performance tweaks. The nice thing is that we have a very good test infrastructure, and we can check on regressions in our performance, etc. Oh, and last week we added our IOU ring module. Hurrah! Which, I mean, it was hard to test because we already saturate the wire for most use cases. But by doing in-memory, doing an in-memory file system, loopback, Met's got around 20% improvement in read. We're not sure. I mean, this is our first implementation. It will hopefully get better. But yes, we are modern and cool, and we use IOU ring like all the cool kids do. I'm sorry?
Gives you a nice little thread pool.
So Christoph's comment is it gives you a nice little thread pool. Yes, but it's one that we didn't have to write, which is the best kind of thread pool to use. So clustered Windows semantics, persistent handles are always going to be hard and slow. So for persistent handles, I don't know if you're aware of it, essentially the goal is that a client can connect to a persistent handle, give a persistent handle on a cluster. The cluster can go down for 100 years, and when it comes back up, if the client comes back and gives the handle back, you better grant the persistence that you offered it. So this is expensive and hard. We have a plan for doing this. It will probably, it needs funding, which we're trying to arrange. It will probably get done for Samba X, 4.x, where x is greater than 12, because I know it's not done for the next release, which is due reasonably soon. There's a lot of improvements that are going on in Samba has a cluster manager called CTDB, and we've now got that into our continuous test environment, which is rather nice. And the goal is to get to the point, CTDB is great, we use it, some products use it. A lot of OEMs basically say, I have a distributed file system, I already have a cluster manager, I don't want yours. Ours is better. They may be right. So the goal is to decouple CTDB from Samba such that the clustered databases that we need to do all of this work, the share modes across different nodes on the cluster, front-ending a distributed file system, can be done by external cluster managers, and the thing isn't so much tied together, so make it a lot easier to use for OEMs. Let's see. Yes. So we originally wrote our own crypto, which is a terrible idea, but at the time, there were a lot of there were essentially no libraries that did what we need. Now, and this is some work from Red Hat, which I'm very grateful for, they basically went back to the GNU, because they're maintaining GNU TLS, they went back and essentially said, all right, what does Samba need? And they went and implemented those pieces in GNU TLS. And as you know, nobody should be writing their own crypto, just like nobody should be writing their own thread pools. So It was very nice. We were able to get rid of a boatload of code, standardize on GNU TLS. We still have a little bit of crypto code left. I'm not sure exactly which of the algorithms it is. But there's some really old ones that Windows depends on that GNU TLS doesn't do. So we still have a tiny bit of crypto code left. And of course, using GNU TLS allows us to use the hardware encrypt on modern Intel processors, which is very nice. Samba, for a while, kind of split into two. And then we managed to get the band back together again. And while that was going on, we ended up with 2 different RPC server implementations and 2 different RPC client implementations, which actually, although it's an absolute pain to manage, and we're now trying to put them back together so we have one of each, it's really useful for testing. Because when you end up with 2 competing teams doing implementations of the same thing, you end up finding some interesting bugs. But really, long term, we need to have one RPC server implementation, one RPC client implementation. And so that's, there's actually a patch on GitLab right now that I think it's still being reviewed. It's not yet in master. I'm hoping that might make it for 4.12. If not, it'll be in 4.13. The next thing we need is fully asynchronous RPC calls. So an RPC call comes in, we do the essential, the send, the receive, callback, so we can handle these things with an underlying threaded mechanism or just asynchronously. And you need that for what's called the witness service. The witness service is what allows SMB clients to say, oh, I'm going to open an RPC handle on this server. If you're going to go down and I need to migrate my connection to somewhere else, please reply to that RPC request and let me know. So it becomes an asynchronous RPC, that's outstanding for as long as the server is alive. So that's the witness service. The other work that's being done is some OEMs, they're like, well, we have our own SMB file server, but we don't want to do the RPC stuff because it's DC RPC, it sucks, it's nasty, it's NDR, it's horrible, it's full of bugs, which is the very definition of DC, I think. And so they would like to do their own SMB code, but they don't necessarily want to have their own RPC server because it's ugly and we've already done it. So there's some work going on to separate out the RPC services so that third-party SMB servers can actually call into Samba. They can run Samba just for the RPC services and use their own SMB implementation, if that's what you want to do. So here is speculative stuff. I'm sort of talking about Steve's company here, and they've talked about this publicly, so I'm not sort of revealing anything. They have experimental servers and clients running over Google Quick protocol. Why would you do that, is the question. Well, the problem is, if you want to do SMB over the internet, and the Microsoft Azure file server allows you to do SMB3 over the internet, encrypted, secure, et cetera, the problem is a lot of ISPs block port 445, which is what SMB uses to connect. So SMB over Quick, which they're happy to open, how they've done it, they're happy to document. SMB over Quick basically will allow SMB to become a real internet file serving protocol because it will be impossible to block because it's running over HTTPS port 443. So we've looked at this. The thing I'm trying to figure out right now is essentially what we need is a port mapper. Because it's coming in on the encrypted, TLS, HTTPS port, when it comes in, normally it's talking to a web server, so you then have to demultiplex to say, no, really, I would like to talk to an SMB implementation instead. I have no idea how that would work on Linux right now. Essentially, it's something like the old port mapper mechanism where you would connect to something and it has to demultiplex and hand the connection over to somewhere else. So I don't know how that's going to work. Still looking at it. Exactly. I think CIFS at this point is not going to get resurrected. It'll be SMB3 over the internet. But I mean, in terms of using the protocol in the modern cloud world, this is the future. This really will be the future because the ability, and we demoed this actually, was it 2 or 3 years ago at SNIR, the Storage Network Industry Conference. We demoed, I think it was Mac Windows, Steve's Linux client, SMB client, Visuality proprietary client, SUSE using the GNOME file browser, all of them connecting. Now, admittedly, we were doing this over port 445 on a friendly ISP, but we demonstrated all of these clients talking directly to a cloud file server, and everybody seeing, somebody would upload a file, someone could download it and edit it, etc. And it's, quite as simple as being able to do net use the cloud, which is really, really powerful. And probably this is why we're still employed working on this stuff, because it's...
Probably Rob's making so that Apache or a web server can just have the socket you got over Unix socket to Samba.
Yeah. Yeah, so the comment from Dave is you need some mechanism handing the socket over to Samba and saying, hey, this is yours, whatever. I agree. I just don't know what that looks like yet. I don't think anyone has... I don't know which of the open source web servers do Quick yet. I haven't seen any implementations in Apache. I don't know whether they do that yet. But because Quick is not just for web services, it can be used for anything. It's the new TCP, basically. So there has to be some way of essentially port demultiplexing from an incoming connection. Yeah, I don't know what this is going to look like. That's why I say this is speculative stuff. But I think it's the future that we're going to be in. So Active Directory, there's been a lot of work on that, scaling improvements. You can have 300,000 users. We're doing a pre-fork model to speed things up. The smart code authentication, it's got JSON audit and security logging. There's some European governments who use this quite heavily. It's got some missing features, mostly around the web services stuff, which is actually SOAP over some crappy web services port. I hate web technologies, which is a bit ironic of being I'm working in Google, but they're sort of more complex for their own good, and unfortunately, a lot of the modern Active Directory stuff requires that. And we don't want to be in the web server business. I mean, I don't really want to be in the SOAP business either if I can just get a SOAP library that we can use to do the parsing. It'll probably be just as buggy and full of security holes as every ASN1 library in existence, but what can you do? So yeah, Active Directory, a lot of the work for that is done by a New Zealand company called Catalyst, and that's basically mostly their thing. So modernizing, keeping us around, modernizing the product infrastructure. We're very old. By 2021 or 23 or so, we're almost as old as the Linux kernel, or maybe older, depending on how you count it, from when the first release was. So we moved to GitLab rather than GitHub. Like GNOME, GitLab is a little bit more free software friendly. So where the cool kids are, most of our project workflow integrating patches has now almost entirely moved to GitLab, which is very good, because it means drive-by contributors use the mechanisms that they're used to. It was previously we would require them to send a patch to the mailing list and join the mailing list, whatever. Now they can literally upload a patch to the GitLab repository, and it'll run all the continuous integration tests. So there's like I don't even know how many tests are, but they take hours to run. But there's a whole battery of test suites that get run on every single check-in. And at least now you can say, hey, my drive-by patch, at least it passed all the tests, so I know I didn't explicitly break anything. And we keep the quality up by essentially still requiring 2 team engineer review before anything goes into the master repo. And we're not crazy, so the master repo isn't on GitLab. It actually is still on Samba.org, and we kind of mirror from there and copy things over. Fuzzing, there was a lot of work originally. I'm running out of time, I think. A lot of work done originally with Codenomicon, which was a proprietary tool, wonderful tool, got bought. Now we probably couldn't afford to run it. So there's now been a lot of work done integrating with OSS Fuzz, which has actually been finding some bugs in code that I thought was stable for over 10 years. So that's kind of embarrassing, but there you go. So yeah, the quality is being kept up essentially by the continuous integration testing. I think we're in pretty good shape. With the SMB1 test being moved to SMB2, And of course, these days, no new features get added without the test being added first. So general free software SMB updates. Ronnie Salberg created libSMB2, which has been added to the Samba project. It's not, when you check out Samba, you don't get it. It's a separate Git checkout from samba.org. But it's a tiny, tiny 140 kilobyte SMB2 library. So, you know, if you want to put SMB2 in your light bulb, you could probably use this thing. It is only dependent on libc, other than Kerberos libraries if you want to have Kerberos. It does encrypted connections. It has 0 copies. So that's kind of cool. And the other thing is there's an experimental in-kernel SMB2 server written mostly by Samsung, KSMBD, and that's on the way. That's interesting. Maybe, like most things in Linux kernel, it'll end up eating the world. I don't know. There are some things that it's a lot easier to do in a user space server, such as clustering. It's quite hard to do in an in-kernel server, but that's being evaluated. They're running our test suites. They're running the kernel client test suites. So yeah, there's SMB. Kind of, it's everywhere. And you know, like I say, with Ronnie's library, this thing is minute. You can. I think he actually put it in some game controller because somebody wanted to have it load the game cartridges, spoof load game cartridges from some file server on someone's home. So this thing literally fits just about anywhere, so that's kind of fun. And I think that's it. Yes. So does anyone have any comments, questions, queries? Yes? Oh, cool. So Dave tells me that there are experimental patches for Quick. So I should probably take a look at that. Have they got a good C Quick library yet? The last time I looked, it was a C++ one. Okay, I'll take a look in Apache Quick, and maybe, yeah, maybe we can get something. Maybe for the next Vault, we'll be able to demo Steve's client talking to Samba over Quick. Yeah. So, I'm sorry? Oh, you have a, so I'm sorry, who are you? You are Cloudflare? Yeah. Oh, cool. So Cloudflare, that's another comment. Cloudflare has a Rust Quick library with the C API. Is that client or server? Or both? Okay. Well, we'll Google for it anyway. So, yeah. Yeah, I mean, I think Google's Quick library is C++ right now, which is a pain to use. I don't know that there's a nice, easy C callable library, but if you've got one that's callable from C, maybe we should use yours. What license is it under? Do you know? Okay, he's checking for me. Thanks. Well, let's.
By default, it's MIT or something.
Oh, that would work. That would work great for us. Anyway, so any other comments or questions? All right. Well, thanks very much.